Okay, so sorry, just now the video stopped. Okay, we continue. So imagine that when we have two dimensions, so we will draw our xy axis like this, right? Yeah, x axis, y axis. This is two dimension. All right, so imagine just how we say we rotate this clockwise, yeah, until we get something like this. The y-axis point this way and the x-axis point this way, and you see, yeah, okay, we add the third axis z. So now you see the y become like this, the x become like this, and the vertical one will be the z-axis. All right, so on this horizontal plane, okay, we call it, okay, we call this plane xy plane because it's horizontal. So you see that your z-axis is counted like this, unit 1, 2, 3, 4, 5, 6, right? So on the horizontal plane, the z is 0. All right, so this xy plane, the equation of this plane will be z equals 0. Okay, and this vertical plane, this is the only horizontal plane. So this is vertical plane. So this vertical plane, we call it xz plane. All right, can see, okay, xz plane. All right, so you see that on this xz plane, you have x, you have z, but you have no y. Because this plane lies on here where y is equals 0. Therefore, this plane also, we name it as plane y equals 0. Okay, so do the third one, this one. So this one we call it YZ plane. YZ plane. YZ plane. All right, so you have y coordinates, you have z coordinate. So you see that on this plane, your x is 0. No x, only any point on this plane only have y and z. No x. Therefore, this plane also we name it as x equals 0. All right. So this is xy plane. The equation of the plane is z equals 0. All right. This is yz plane. The equation is this is xz plane. So the equation is y equals 0. All right. And the third one is yz plane. Then the equation is x equals 0. All right. So this is a three-dimensional diagram. All right. Okay, now we go back to the notes. So this is the first one, how we name all the three planes. Okay, second difference is the idea of the gradient of a line does not carry over into three dimensions. Means in two dimensions we have the gradient of the line. In two dimensions we have gradient of the line to show how slant the line is. But in three-dimensional, the gradient of the line actually bring no meanings. Because three-dimensional, it can be in any direction. All right, so there's no meaning to mention about the gradient of the line in three dimensions. So however, reasons why vectors are especially useful in three-dimensional, because when we use three-dimensional vectors with the coordinates x, y, z, it actually show us the actual position of one object in the three-dimension space. All right. Okay, then the third concept that apply into three-dimensional is, so in three-dimensionals, lines which are not parallel may or may not meet. So we know that in two-dimensional, we know what is parallel line, right? In two-dimensional, so let's say I have two lines parallel. All right, so the concept of two parallel lines means they never meet each other. Parallel lines never meet each other. But in three-dimensional, there are lines that are not parallel. Parallel means same direction. They are not parallel, but they also never meet each other. So these are the two examples. Okay, let's say in this cube, line L1 is on the top surface. Line L2 is at the bottom surface. So they are not same direction, right? One this side, one this side. But they are not parallel. They are not parallel, but they will never meet, right? This one forever on top, this one forever on the bottom. So when you see this box, Cannot see. Two. Okay, when you see the box again, you imagine lah. One is on top of the box. Let's say this one. Okay, one is on top of the box. Okay, another one is below the box. So forever they would meet each other. Okay, so another example is the pyramid. All right, so L1 is here on the horizontal plane. L2 is like this, going up. So they are not parallel because not same direction, not parallel, but they will never meet. No matter how you extend these two lines, they will never meet. So this type of lines, which are not parallel but never meet, we call it skewed line. Skewed line, say to be skewed. So this only happen in 3-dimensional. Or 2-dimension, there is no skewed line skewed lines like this. Okay, so this is the concept of 3-dimensional. All right, so next we will go to 6.1.2.1 position vector. Last video, the first video, we have discussed a little bit about position vector, right? Okay, so the position, remember the position vectors that we mentioned last video. All right, so position vector, let's say AB is OB minus OA. When we talk about position vector, it's always related to the origin. And I explained to you how to get this formula, right? So now we will go further into this position vector. Okay, position vector is displacement vector which begins from the origin. It's always related to origin. Okay? It's always related to the origin. Origin. And position vector in 2 dimensions. This is what I have discussed. So you just go through very fast. So if O is the origin, so OP is known as the position vector of P relative to O. This is a full name. Vector OP means vector of P relative to O. So P is X unit from O in the direction of X-axis. Alright? Means like this. From O, if we want to reach P, we are going to move X unit in the direction of X, then move Y units in the direction of Y-axis. Then we reach here. Alright? So the point P has the coordinate XY. So suppose that I and J, still remember I and J, they are unit vector on the X-axis and Y-axis. Means in this unit, in the direction of X-axis and Y-axis. So if point P has coordinates XY, then the displacement of P from the origin will have the component xi plus yj. Alright, so in the x-axis, the vector with one unit only is 1i. So 1i, 2i, 3i, 4i. Okay, go up is j. One unit is j, 1j. So 1j, 2j, 3j like this. Okay, therefore the position vector of P relative to O is given this. OP equals xi plus yj. Alright, and OP, vector OP also can be expressed in column vector form. It is like this. This is in ij form. This is in column vector form. So we will solve by something like matrix. Alright. Okay, so for any 2 points P and Q, the position vector of Q relative to P. So vector PQ means vector Q relative to P will be OQ minus OP, which O is the origin. This one I have explained. Like what we have done here. Okay, so we can skip this. Alright, so this is in 2 dimensions. Okay, how about 3 dimensions? Position vector in 3 dimensions. Okay, if O is the origin, so vector OP is known as the position vector of P relative to O. Alright, this diagram maybe not that clear, but doesn't matter. Later I show you. Okay, so P is the X unit from O in the direction of X. P is Y units from O in the direction of Y axis, and Z units from the O in the direction of Z axis. Therefore, P will have coordinates X, Y, Z. Alright? So maybe I use this 3-dimensional diagram to explain again. Alright? So look at this diagram. Let's say imagine this is an object. Alright? This is an object hanging in the 3-dimensional space. Okay? So from this object, sorry, hold on. All right. Okay, so this is the object hanging in the three-dimensional space. All right, so how we are going to name the position of this object? All right, so you imagine that, okay, this is the object, so this is the vertical distance direct from the object go down to the horizontal plane. All right, so this is the position, vertical. All right, can all right, so you see from the origin I want to move until this object. How can I move? So first we look at the horizontal plane first. So as I say lah, this one is vertically down below the object. So from the origin I have to move x unit. I have to move x unit in the direction of x-axis. Let's say until here. Okay, I use other color pen. Okay, move from 0, move in the direction of x-axis until here, x unit. Okay, then move in the direction of y-axis, move in the direction of y-axis, y unit. Then right here. See, so from the origin, move in the direction of x-axis, x unit, then move in the direction of y unit, in the direction of y-axis, y unit, right? Then move up, right? Move up. Okay, move up. So move up k unit in the direction of z axis. See? So move x unit in the direction of x axis, move y unit in the direction of y axis, then move up k unit or z unit in the direction of z axis. Then we get the actual position of this object, which is x, y, and z. All right, so the x, y, and z, actually this is the meaning of the the coordinates, the triple ordered coordinates x, y, z, to explain where is the actual position of the object in the three-dimensional. From the origin, always from the origin, move how many units in x direction. It can be positive x direction, it can be go to that way, negative x direction. Then move, followed by move y unit in the y-axis direction, then go up. Or move how many units up or down lah, up or down lah, because you have positive, negative ma. So to get the actual position of the this object. All right, so this is the concept. Okay, go back to the notes. All right, so we have explained this side lah. If you have an object in the three-dimensional, what is the meaning of this x, y, z? Okay, then second, suppose that I, j, k are the unit vector on the x-axis, y-axis, and z-axis, unit vector. So if point P has the coordinates x, y, z, then the displacement of P from the origin will have component xi, yj, and zk. Therefore, the position vector of P relative to O is vector OP, which is xi plus yj plus zk. All right, and again, vector OP can be expressed in column vector form like this. Also, two-dimensional and three-dimensional also the same. All right, and the column vector for I is the xi ma, so 1 unit. Y and z 0. J is in the direction of y, so y have 1 unit, x and z 0. And unit vector k is in the direction of z-axis, so xy 0, k equals 1. Okay, all right, so next 6.1.2.2, magnitude of a vector. So we have explained magnitude. We can represent by this magnitude symbol, all right, or we call it modulus. And for two-dimensional vector xi plus yj, then the modulus of vector A, very simple, right? This one, square root x squared plus y squared. All right, and if A is in three-dimensional, which has the vector xi plus yj plus zk, then the modulus of vector A will be square root x squared plus y squared plus z squared. All right, prove it. So how we can prove it? Okay, so we will look at this diagram. Okay, can see. Okay, so let's say I have a three-dimensional plane, or x, Y, Z. Please get used with these three axes. The horizontal one is Y. So Z to this direction. But remember, they are perpendicular to each other. X and Y perpendicular. Then Z going up. So Z and Y perpendicular. And Z and X also perpendicular. Alright. So like this diagram. Remember this box. Okay. So they are perpendicular to each other. Alright. Alright. So let's say I have a point P here hanging in the three-dimensional space. Okay. With coordinates X, Y, and Z. How we can get the modulus? So the modulus is from origin to P, right? OP. This is vector OP. How we can find the modulus? Okay, so this is the way. So again, from point P, we draw a line vertically perpendicular to the XY plane. To the XY plane. Perpendicular, see? So this is like the shadow lah. Imagine there is a lamp, there is a light here. So when the light on, so the object P is here, so the shadow will be here, right? Just vertically perpendicular to the XY plane. Okay, so let's say I name this point as P prime. Okay, so first step, we look at the horizontal plane first, the XY plane only. Look at the green color one. Okay, so from origin, how I can go to this P prime, the shadow. So means that you are going to move from origin X unit in the direction of X-axis, right? Then Y unit in the direction of Y-axis. This is perpendicular, see? Then you will get to P prime. Therefore, because this is perpendicular, so by using the Pythagoras theorem, so the OP prime will be X squared plus Y squared square root, right? This one very simple. Imagine, so I redraw this OXP prime again. So you see that this is OP prime. It's perpendicular. So by using Pythagoras theorem, you get this. No problem, right? Okay. Now, when come to this point already, now I'm going up Z unit, right? I'm going up Z unit. So now I will consider triangle OP prime P. OP prime P. I redraw out the triangle OP prime P. So P and P prime actually perpendicular, right? Okay? Therefore, to find OP, again we are using Pythagoras theorem. So to find OP is OP prime square plus PP prime square, right? Okay, so what is OP prime? OP prime square. So this is OP prime. So after square means no more square root. So OP prime square is X square plus Y square. Alright? And what is P prime P square? Going up Z unit, right? Going up Z unit. So Z square. Okay? So OP prime is X square plus Y square. Plus, going up is Z. So Z square. So square root. So this is how we get the formula for the modulus of vector OP in three-dimensional. By formula is very simple. Two-dimensional X squared plus Y squared. Three-dimensional X squared plus Y squared plus Z squared. But how to get this formula? Yes, you must know the step. Alright, you must know this step. Okay? So this is related to modulus. Okay? Then next, we will see some example. Example 6.1.2.2 related to the modulus. Alright, so the first question. Calculate the magnitude of the following vectors. So three questions. Alright, so question A, very simple. Can you see? Okay, we do it here. Alright, so this is vector C. Alright, so horizontal, this is two-dimensional. This is two-dimension. So horizontally, 1, 2, 3 unit. So 3. Go up, 1, 2, 3, 4 unit. So 3 and 4. So modulus C will be square root 3 square plus 4 square, which is 5. Alright, and then vector AB is 6i minus 7j. Vector AB. So remember I said printing bold. But when you write, you must have the vector notation, like this. Therefore, the modulus for vector AB will be square root 6 squared plus 7 squared. Doesn't matter the negative. Negative is just to show the direction. But what we want is the magnitude. We don't see the negative. Alright, so it's square root 85. So this one cannot simplify anymore lah. We just left it like this. Okay, and C is three-dimensional. So you are given vector A is 2i minus 4j plus 5k. Alright, then the modulus is very simple. Square root 2 square plus 4 square plus 5 square. Alright, so it's square root 45. So 45 is 9 times 5, right? So square root 9 is 3 lah. So 3 square root 5. Okay? Alright, so number 2. Question 2. If the coordinate of P is 1, negative 2, 4, find the position vector of P, alright, and the magnitude of OP. Then find the unit vector in the direction of OP. Not difficult. So this, you are given the coordinate x, y, z. So vector AB will be very simple. X is 1 ma, so 1i minus 2j plus 4k. That's it. Alright, so magnitude is 1 square plus 2 square plus 4 square. So square root 21. This is already the simplest form. Okay, and remember the unit vector. So the unit vector in the direction of OP. So all the x, y, z divided by the modulus. Okay, and we don't want cert at the denominator, right? So all the terms multiplied by square root 21 over square root 21. So it becomes like this. Alright? Okay, question 3. So you are given points R, S, and T having these coordinates respectively. So the question wants you to find R, S, and ST in terms of IJK. So R, S, T, you are given the coordinates of R, S, T. So I write the position vector for OR, OS, and OT, just expressed in IJK form. Alright, so the first one is you're asking to find RS. So by using the position vector formula, RS is OS minus OR. So this is OS minus OR. So remember, minus, put the bracket. Alright, so 3i minus I, 2i. J minus 3j minus 2j. 4k minus 2k, 2k. So this is RS. So I do this in IJK form. So I show you another one, the column vector form. Remember, column vector? So you're asking to find ST. So by using the position vector formula, ST is OT minus OS. Alright, OT minus OS. So this is your OT. I write it in vector column vector form. T 4, 1, negative 5. So 4, 1, negative 5. Okay, minus OS. OS is 3, 1, 4. 3, 1, 4. Then just minus only 4 minus 3, 1. 1 minus 1, 0. Negative 5 minus 4, negative 9. Alright, actually, if the question never say anything, we can just leave it in this way. But this question, they want you to express in terms of IJK. So we have to rewrite in IJK form. X is, I is 1i. No j, right? 0 ma. So don't have to write j. You don't have to write 0j. Just omit it. Okay, and minus 9k. Okay, so very simple. Just simple calculation. So this is the solution for question 1, 2, and 3. Okay? Alright. So next, question 4. Alright? Question 4, show that the 3 points whose position vector are this one, and this one. 3 points are collinear. Okay. Collinear. What is collinear? I remember the first video we have discussed one question for collinear. Do we? Never mind. Okay. Okay. So before I go to the question 4, we see a little bit the concept of collinear. Again, collinear you have learned in SPM also. Alright? What is the meaning of collinear? Collinear means all the 3 points, okay, lies on the same straight line. A, B, C. This is the meaning of collinear. Alright? So if you want to show 3 points are collinear, lies on the same straight line, first step, we must find the relation between the vectors or number, doesn't matter lah, or vector. Okay. Alright, you must show this one. Either one pair. Or either you say AB equals to lambda BC. Remember you said, the first video we say the relation between two vectors. Or n equals to mu AC. Alright, you can find the relation between remember we said that if you have any 3 points, we can form 3 different vectors. Alright, AB, BC, or AC. Alright, 3. So you find either one pair. Either you want AB and BC, AB and AC, or BC with AC, anything. Okay, let's say now I choose this one. Okay, I get AB and I get BC, and I can find the relation between them. Or I can find this relation. So when you can find the relation, you can make conclusion. AB parallel to BC. So when you get this relation, remember you only show that they are parallel. When you find the relation, they are parallel. Yeah, the first video when we talk about parallel vectors. Okay. So how to show collinear? So to show collinear, you have to add one more thing, which is a common point. They are AB parallel to BC, means same direction. AB, BC, same direction. Of course, same direction, AB, BC, right? Then you have to mention the common point. So between AB and BC, the common point is B. And the common point B. So you must show these two things, parallel and common point. Once you can get these two, then you can make conclusion A, B, C are collinear. Alright, so this is a concept for collinear. Okay, so let's look at this question 4. Okay, so question 4 say, show that the 3 points whose position vector are this are collinear. Alright, so I give it some name or easier for our calculation. Alright, I give it a name. Let's say the first vector 2i 3j minus 4k is OA. Alright, I write in vector column form. 2, 3, negative 4. So OB is 1, negative 2, 3. This one. Okay, and OC is no I, right? No I means 0 or 0, negative 7, 10. This one. Alright. So I name it OB. I rewrite these 3 position vector OA, OB, and OC. Alright, and we want to show ABC collinear. So as I say, we want to find the relation either 2 pairs. So for me, I choose AB and BC. Alright, so to find vector AB is OB minus OA. This is OB minus OA. So this is AB. Alright, so the next one I choose is BC. So BC is OC minus OB. So this is OC minus OB. So I get this. Okay, of course you can use AC. Up to you. So I choose AB and BC. So when you compare, they are the same, right? Therefore, vector AB and vector BC are the same. So this is the meaning relation. Find their relation. Your lambda now is 1. Okay, so when I get this relation, I can make conclusion AB and BC are parallel. This is a symbol for parallel. AB parallel to BC and a common point B. See? Therefore ABC collinear. Right? This is to show 3 points are collinear. This is in 3 dimensions. It can be used for 2 dimensions. Same. Alright? So next time when you have question related to collinear, so please refer back to this example. Okay? Alright. Okay, so question 5. You are given 2 sets of point A, B, and C. Determine whether point C lies on the line AB. Whether C lies on the line AB. Actually, same as collinear if you have line AB and C lies on it, means show ABC collinear Okay, so there are 2 questions here. Alright, so if you are given point A, point B, and point C. So I want you to do this question as quiz. So right after this video, do this question and forward it to the folder. To the folder that I give you the notes and the revision set. Alright? Upload to that folder. So B will be your homework. B will be your homework, and your another homework will be checkpoint 6.1, question 3 to question 5 homework. Alright, so means that altogether you have, oh, just now no homework, huh? Okay. All right, so your homework only this question. Okay, and checkpoint 6.1. Okay, quiz is A. All right, okay, see you. Thank you, class. I will see when I complete next video, then I will forward again. All right, okay, thank you, class.